Okay. Good morning. Although I just have to say, I really don't like Tuesdays and Thursdays because, like, it's barely morning. It's already 11 o'clock, and it's third period. I just have to say, it's messed up. Don't like it at all. All right. Okay, we are solving exponential equations again today, just like we did yesterday, except they're a little more challenging today. We are still using the one-to-one property. What did the one-to-one property say from yesterday? If b to the u equals b to the v, then u is equal to v, which means if the bases match, then the exponents must be equal to each other, okay? And we are going to use this a lot, this property, the idea of this property. All of these powers are good to know. You're going to see this a lot. I do want to remind you that you have a test on Monday. There is extra credit posted on the class website under announcements. And we will review tomorrow. And that review you can use on your test, which means, is it helpful to just write answers? No, answers are useless. Work matters. So use your notes, show good work, show how to do stuff, write down words to help you. Don't just write answers, which a lot of you did on the last review. All right. So I'll turn back to this page if you haven't finished your powers, but here we go. This is it for today. Please take good notes. Do not smush things. Use paper. Use up space because you want to be able to add special notes. That's called annotations, adding extra notes. We want to solve each equation. We have 1/7 to the 3x plus 8 power times 343 to the 3x power equals 1 over 343. Now, when we look at a problem like this, it's pretty complicated. We're going to have to, the first step is always to rewrite with the same base. This is an annotation. We're adding a note to ourselves that we can read later to help us, okay? If I write this down, so should you. Step number 1, rewrite with the same base. So what we're doing is I'm looking at these numbers, all of these bases, and I need them to all have the same base. So if you look on your power sheet and you look for the number 7 and the number 343, what base can I rewrite them using? Cube. 7 to the 3rd. Yeah, so 343 is the same as 7 to the 3rd power. Now, what we don't want to do is forget about those exponents that are already there. So don't leave those behind. Make sure you take everything. But I'm going to trade out the 343 because 7 cubed is the same as 343. How do I get a fraction like 1 over 343? Negative exponent. Very good. So that's going to be 7 to the negative 3 power. Very good. And we've got a product here. And then I also have this 1/7 that I want to rewrite as 7 to the negative 1 power. So again, now all of our bases use a base of 7. Don't forget the exponents that already exist. So those are all getting brought along for the ride. So our first thing was to rewrite so that everything has the same base. And you can see base of 7, and a base of 7. And now we need to clean up our powers. Because I have this weird thing where I have 3 raised to the 3x. What do you do when you have a power raised to a power? What do you think you do? Multiply, yes. You might need to multiply your exponents. So this is another little annotation here. We get to multiply our exponents to clean this up. Here, this is -1 times 3x plus 8. So we need to distribute that -1. That's going to become what? I distribute my -1, what do I get? -3x minus 8. Very good. -1 times 3x is -3x. -1 times 8 is -8. Here, we have a base of 7. I'm going to multiply my powers together. 3 times 3x gives me 9x. Over here, my exponent is fine. Now, before we can do anything, I have to simplify my left-hand side here. I need to clean this up. These things have the same base, so I get to keep my base. What do I get to do to the exponents? Add the exponents, yes. In a product, we get to add the exponents and keep the base the same. So I have -3x plus 8 plus a 9x. What does that give me? -3x plus 9x is 6x. Good. With a -8 there. Is equal to, we have a base of 7 to the -3 power. Now we are in b to the u equals b to the v. This is our one-to-one property that says if the bases match, what must be true? The exponents are equal as well. So 6x minus 8 must equal -3. How do we solve from here? Add 8. So we get 6x equals 5. And then divide by 6, divide by 6. So x equals 5 over 6. All right. Any questions on the first one? Okay, lots of cleaning up, really. That's what we're doing, just cleaning things up. All right, over here on letter B, got 64 to the power 3x plus 1 over 256 to the -x power equals 16. And the first thing we need to do is what? What's the first thing? Rewrite with the same base. Thank you. That's why we wrote that down. So I can see here I have a base of 64. I have a base of 256. And I have a base of 16. So go back to your powers page. Base of 2. So 2 has, a base of 2 has all these numbers. Is there another one? 4 actually would also work. It doesn't matter if you choose a base of 2 or a base of 4. I'm going to choose a base of 4. Because that's going to have smaller powers, smaller numbers. So that's what I'm thinking about, keeping things small. All right. So I want to rewrite these things using a base of 4. So how could I change 64? 64 is 4 to what power? 4 to the 3rd. And I'm not going to forget my 3x plus 1 up there. All right. 256 can be rewritten as 4 to what power? 4 to the 4th. And I'm not going to forget my negative x power. And then 16 can be rewritten as 4 to the 2nd power. All right, so I'm trading numbers in for powers. Now, what do I do to clean up these exponents? Multiply our exponents. Clean them up. So if I multiply my exponents there, I'm going to get 4 to what power? 9x plus 3. Yeah, I got to distribute there. So you do have to distribute that 3. 3 times 3 is 9x. 3 times 1 is 3. My denominator, I have a base of 4. And again, we multiply our powers. 4 times negative x is negative 4x. All right, now I have a giant division problem. What do I get to do when I have the same base in a division problem? Subtract the exponents. Subtract exponents. Subtract the exponents. And this is a tricky step, so I'm going to do it very carefully to show you how we do that. My base stays the same. The base of 4 stays, and we do the 9x plus 3, the top, minus the denominator's exponent. So minus a negative 4x, top minus bottom. So you do have to be very, very careful. What's that going to give me? Yeah, 9x minus a negative turns to positive. So we get 13 x's. 9x's plus 4x's is 13x plus 3 equals 4 to the 2nd power. Now what can we do? This is our one-to-one property. Do our bases match? So what must be true? The exponents match. U equals V. The exponents match. So 13x plus 3 is the same as 2. And what do we get? What can we do? Subtract 3. So I get 13x equals negative 1. And then divide by 13. So I get x equals negative 1 over 13. Okay, lots of steps. All of these are annotations. I totally always encourage you to write those things down. They are really helpful. Okay, little rule reminders. All right, do you have questions for me? All right, you guys are finishing up yesterday's worksheets. The answer key is on your round table. And you should have time to get that done before you leave, okay? There is extra credit posted when you finish your homework. And I'm passing out